From our Lakeview studio in the Windy City, welcome to Chicago Python Tonight. Hi, everybody. My name is Ali Sivji. I will be your host for this evening. So I'm one of the Chippy organizers. So I'd like to thank everybody for coming to our WebDev / DevOps special interest group event. So I do want to let everybody I do want to make everybody aware that we do have a code of conduct. Sorry, I was getting a little bit of reverb, just turning that off. So everywhere you're interacting inside of our YouTube chat, on our Slack, all of those are going to be following the code of conduct. All of that information is available on our website. Also, what is Chippy? Chippy, or the Chicago Python Users Group, is a Python community that was started back in 2003 when a few Pythonistas started to get together around once a month to talk about their favorite programming language. And we've grown from those humble beginnings to become one of the largest Python user groups in the world. We have around 6,000 members, and every month we hold 4 to 6 events. So our main events are the main meeting, and that's our signature talk night that happens on the second Thursday of every single month. We also have a monthly project night that's on the third Thursday of every month. We recently started making that a virtual project night. And we also have a mentorship program that's going some changes right now. So stay tuned. Check out our website for additional information in the coming weeks. We also have special interest groups that cater towards more of a niche application of Python. We have a data special interest group, one for web development / DevOps. We have one for algorithms and data structures to help folks get better at those whiteboarding type questions. And we also have a finance SIG, since Chicago is one of the big finance hubs in the world. We just want to make a few announcements. Today was actually supposed to be the last day of PyCon. We were supposed to be having the last day of open source sprints. PyCon tradition usually means that Larry Hastings is like the last one to leave the sprint session. So unfortunately, that's not happening tonight, but it's hopefully it can happen again next year. But PyCon has actually moved from Pittsburgh to online. So a couple of weeks ago, they started releasing videos on their YouTube channel. So if you go to us.pycon.org, you can find out all about that. I think videos are going to be coming out in waves over the next few weeks. We do have some virtual events happening at Chicago Python. We're actually back to our full lineup of events. Just shout out to all the organizers working hard to make that happen. On May 7th, we're going to have our first virtual algorithm SIG night. On May 14th, we're going to be live streaming our main meeting onto YouTube. On May 20th, we're going to be doing a data special interest group that's also going to be live streamed onto YouTube. And May 21st is going to be our second virtual project night. We're going to meet on Slack and then move into different breakout rooms depending on what projects you want to work on together. Where can you find us? We have a very popular, very active Slack workspace, around 2,000 members. You can check out our Heroku app page to invite yourself to that workspace. You can also find us on Twitter. We are at Chicago Python. And all this information plus more is on our website. We have 2 fantastic talks. We've been getting a lot of great submissions for WebDev / DevOps SIG. Really happy to be holding these events virtually. So Andy Knight, also known as the Automation Panda, he's going to be kicking us off with how to get started testing with pytest. And then finally, Josh Dolitsky is going to be talking about using AWS CloudFormation to move our infrastructure into code. I do want to make everybody aware, we do have a Q&A box in this YouTube live stream. So if you're just chatting, there's going to be a little bit of delay. So if you do have questions for our speakers, can you please ask them ahead of time just so we can make sure we have them all queued up? We do have a discussion question for tonight. What is your favorite non-Python programming language? Some of us have to use Python. Some of us cannot use Python all the time, so we have to rely on other technologies. What are some of your favorites? I'm actually going to be on vacation. Well, not vacation, I guess a staycation next week. So I'm going to be getting back into JavaScript. So what are your favorite non-Python programming languages? So I'm actually going to be bringing on our first speaker, Andy. Hey, Andy, are you ready to come on?
I'm ready.
Awesome. Hey, everybody. This is Andy Knight. Andy, can you please introduce yourself to our audience?
Sure. So my name is Pandy, or Andy Knight. I am the Automation Panda. I'm a software engineer and test who focuses on building solutions to testing problems. I also do some random development on the side, like I've developed Django apps and all that. Good friends with Ali. We run around the Python conferences quite a bit. So thank you for inviting me here tonight. And I'm looking forward to sharing a little bit about getting started with PyTest to help you write some better tests.
Awesome. Yeah. Every time I see all my friends on the conference circuit, I'm always telling about how Chippy is like my favorite thing and they should all just come on by. So really happy to bring them all onto this live stream. Also, how did you get started with Python?
Oh my gosh. So I first started Python in high school back in 2006-ish. It was on version like 2.4, whatever. It was part of the survey of programming languages course. And so I was like, wow, this is really cool. So I did some stuff and never touched it again until 2015 when I joined a company where there are 3 languages were Python, Java, and JavaScript. So I had to learn it again and I fell in love with it. It's just so concise, so readable. It's really good for test automation. So Since then, I've been doing Python mostly on my own. I don't use Python in my day job, which is kind of interesting. But, like I've built a Django app for some small businesses. I do all sorts of training on Python, test automation. So I keep it real.
Yeah. So I guess you're not using Python in your daily job. So what would be your favorite non-Python language?
Oh, I was just thinking about that when you asked it. I don't know. I mean, in terms of if I have to like lay down and do something that's not in Python, probably Java. If it's like from the quality of an object-oriented language, probably C#. I think C# is a little bit better than Java in terms of its syntax. If it's just for like really cool, think big kind of stuff, Haskell.
Ooh, Haskell. I like that. Do we have any other functional programming folks in our chat? Please give a shout out. So we're all dealing with the COVID-19 situation. PyCon had to get canceled. I know you're really excited to give your talk and your tutorial there. So how are you dealing with sort of like the fallout of COVID-19?
Man, it's pretty tough. Taking it in stride is the best we can do. So my family and I, we've been staying home. My wife has gone doing crazy awesome things with plants around the house. She's going to start a garden and got tons of succulents. We do our best to stay home, not go out too much. But it's tough. Like you said, we were all hoping so very much to go to PyCon. And not only PyCon, but so many other conferences, just boom, 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 boom. So just trying to stay positive, do the right thing. We've donated some masks and stuff as a family. So, yeah.
Yeah, it's like, I think everybody's sort of getting that sense of being isolated and having that sense of just like wanting to be around people. But I'm really happy to be able to bring folks on and still connect with our community. Awesome. So thanks again for coming on. Are you ready to get started with your talk?
I'm ready.
Awesome.
I hope as ready as I can be.
Do you mind sharing your screen? We'll just get it up.
Sure. Share screen. Boom, boom. View my entire screen. There we go. I know how to play technology. Alrighty. So can everybody see a terminal?
We can see your terminal.
Great. Awesome. So this talk might be a little bit unconventional because I don't actually have slides for tonight. My talk is literally going to be live coding with PyTest because I want to show y'all how to really get started with it, what you can do, how to write some different tests, why you should do certain things and why you shouldn't do other things. So I'm going to be coding. I'm going to be opening up Visual Studio as my editor. I like Visual Studio Code as my editor because I think code is fairly lightweight, but still has a lot of the main features you want for an IDE. So I'm also going to be pulling up some web pages here as I talk. So let's talk about what PyTest is. I'm sure most anybody who's been around the Python community for long enough has probably heard of PyTest, or maybe unit test, which is another test framework. PyTest is a test automation framework in Python. It is third party. It's not part of the standard library. but it is, according to the Python Developer Survey, the most popular Python test framework currently out there. I've got the docs page for pytest open right here. I really like the docs page because it has really good information. And anytime I need to look up something, I come right here and boom, it's really helpful. I also like the first example they have on the page. For somebody who doesn't know much about testing or automation or what pytest is, the reason why we test our code is for two purposes. We want to verify goodness and identify badness. A lot of people think code or testing code is about finding bugs. That's only half the battle, right? We definitely want to find any defects in the software we develop, but we also want to have a peace of mind to say, okay, everything I just did is good, so I can keep moving forward without worrying. If we look at the example here, this is a test case in pytest. Even though it's only 2 lines, it has everything we need. We've got a function, because in pytest test cases are written as functions. It's prefixed with a test underscore prefix to denote that this is a test case function. And inside my function, I'm making calls. For example, I'm making this increment call to this increment function, which is supposed to do something. And when I make that call, I'm making an assertion to validate goodness or identify badness based on some condition regarding this call. So in this case, my increment function, if I pass in a 3, I'd expect to get out of 4. So 4 = 5, this assertion would be false, and this test case would fail. And all test cases are basically written like this. We do some stuff, and we make assertions to see if it's good or bad. Pardon me. That's what pytest does in a nutshell. It lets you line up these dominoes of test cases and knock them down altogether. When you have multiple test cases, pytest will discover them all based on the file name or the function name. It'll execute every single one of them, one after the other. If there's any issues in one, they'll stay localized because it's independent. Each test case is independent. And so a failure in one test case should not affect other test cases. And at the very end, it'll print out this report to explain this is what was good and this is what was bad. So let's write some pytest test cases together. Here I am at my terminal. I'm going to make a new project. Let's call it Shitty Tests. Okay. You can add test cases to any Python project. You can either create a new project containing a whole bunch of test cases in isolation. You can add them to an existing project that you already have.
Andy, do you mind zooming in a little bit more?
Oh, sure. Let me, oh gosh, one moment. Is the text just a little small?
Yeah, just a little bit.
Okay. Oops. Is this a little bit better? Or do we need more? I can do more.
Can we go a little bit more?
Yeah.
As much as you feel comfortable using.
Yeah. Not a problem. I just have to resize my window here. Oh my gosh. Yeah, wouldn't want to make things invisible. All right, here we go. Big and bad. All right, so where am I?
Thank you.
Okay, cool. So I'm in my new project folder. Now you may be wondering, should I make my own project or should I add them to an existing project? That depends heavily on the type of test cases you want to write. If you are writing unit level test cases, meaning white box tests that'll make direct access calls to the code, such as you're directly testing methods and functions, I would say add those tests in the same project as the code being tested. If, however, you are doing some sort of black box test, maybe you're doing integration tests with REST APIs or you're doing web UI tests, that's when you might consider having a separate repository. The advantage of having it in the same repository is if it's in version control, it's all version control together. However, sometimes certain tests test multiple things and multiple pieces. And so if you have an application or some sort of backend thing that requires 3 or 4 different pieces coming together and each of those pieces has their own repository, that's when you might want to have a separate project or separate repository for those kinds of tests. So just think about your needs. There's no necessary right or wrong answer to it. It's just about what's going to help you in your workflow. So because we're doing this as a standalone example for tonight, I'm going to create my own folder, a new project, and put everything in here. So I'm inside of this. And I'm going to use pipenv for managing my dependencies just because it's easy. I want to get pipenv install pytest. So take a minute just to get it in there. Pytest is the only dependency you need for pytest out of the box. There are a bunch of pytest plugins publicly available that you can also add that'll be in separate packages. Things like code coverage or BDD or HTML reports. And if we get a chance a little bit later, I might incorporate some of those. So please don't fail me now. There we go. Okay. So if I look inside my project, I got my pip file, my pip block. I'm also going to create a directory called tests. By convention, all pytest test cases should go into a directory named tests that's under the root directory of your project. That's where pytest by default will go to look up test modules and test case functions. I believe that can be changed, but it's fairly conventional, even in a unit test framework, to have a tests directory. So let me flip over to Visual Studio Code, and let me open up that workspace. Programming. Where are we? I can't even, oh my gosh. There we go, Chippy tests. Oh, it's not gonna let me do that. I have to open as a, my bad. I don't even know my own editor. I'm sorry, folks. This is the fun of live coding, isn't it? Chippy tests. There we go. Okay. All right. So I'll also make sure that this is hopefully big enough. So I have my test cases directory. In here, let's add some basic unit tests just to show how to use pytest. So I'm going to say new file. I'm going to call it test underscore math.py. And this module.
Do you mind throwing that a little bit bigger as well?
Yep, sure thing. So I want to see some text before I do that. This module contains basic math unit. Oops. So let's see, boom, boom. Whoa, is this okay? Do we need a little bigger?
Can we go a little bigger?
Boom, let's try this.
That's perfect.
Okay, cool.
Thank you.
Yeah, it looks like Duplo blocks on my screen, but that's okay.
And do you also mind, somebody asked to hide that notification for Google on the bottom that says hide?
Oh yeah, whoopsie. Oh gosh, I'm so paying attention.
Thanks so much, Andrew.
You're welcome. Thanks, Joe. Okay, so I'm going to hide the tree for the project for now, just so we have bigger space to see our tests. So let's just write some basic pytests. So def test 1 + 1. So again, I'm going to have a test case function, and it's inside of a test case module inside of the tests directory. When pytest does its discovery, it'll go to the test case directory. It'll look for any modules prefixed with test underscore, and inside these modules, it'll look for all test cases that are test prefixed by, it'll find all functions prefixed with test underscore. So that's how I know, that's how pytest knows where to find its test cases. So if I make a basic assertion, assert 1 + 1, what would we expect this to equal? I expect it to equal 2, right? So again, I'm making a call, having my assertion. If I want to run this, new terminal, let's see if I can do it in here. That's not going to be too good. I'll just use the external terminal. So in here, we have, if I, oops, clear the screen, bring it to the top. So we know we have some test cases in our tests directory. From the root of the project, I want to run my pytest command to do the discovery if I want to run the tests. So since I'm in my project root, I have to say pipenv run because I'm using pipenv. To run pytest tests, python-m pytest is the command. I believe you can also run it using just the pytest command. I think that's added to the command line, but I found sometimes that has some weird, funky path issues. Every time I run it with python-m pytest, it seems to work fine for me. So that's what we'll do right now. When we run it, we'll see the pytest banner. It'll show the start of the testing session. in PyTest lingo, the session is the entire run of all of your test cases it discovers. It shows my root directory. It shows that through its discovery, it found one test case. It was in this module, and you'll see a green dot here. The green dot means the test was successful. If you had multiple modules, it'll spill it out here. End of the banner, one test passed. It only took 0.03 seconds. Interesting thing, rule of ones, unit tests typically take about a millisecond. Integration tests with service APIs typically take about 1 second, and end-to-end tests with web UI typically take about 1 minute. So unit tests, very quick. So that's the happy path with PyTest. Nothing terribly earth-shattering here. Let's make it a little bit more interesting. Let's say I have test 1 plus 2. If I'm going to spill it out just a little bit different this time. I'm going to use some variables. So if I say assert a plus b, which 1.2, or 1 plus 2, we would expect this to be 3. Let's screw it up. Let's deliberately inject a failure here and see what happens. I'll come back to my terminal. Let's run the tests again. It should discover 2 tests now. So here, instead of seeing 1, we see 2, and we see a big red F for failure. Anytime you have a failure, PyTest will print out all of the failed test cases with a little bit of introspection and logging. Here we go with the failures. Test 1 plus 2 is the test that failed. We'll see the code for that test case function, which is really nice. You'll see exactly the line upon which it failed. That's this assertion line, assert A plus B equals 99. Now, what's really, really nice about PyTest is it does give you a level of introspection. That's why I used variables here. So instead of just saying 1 and 2, I used A and B. Notice here on the introspection line, it substitutes the values that these variables are. So it's saying assert expression 1 plus 2 equals 99. This is really helpful because if all I were to see is A plus B equals 99, if this were a more complicated test, I may not really know what A and B's true values are. And I'd be scratching my head, what's going on? I might even have to do some live debugging to figure that out. But because of the introspection, PyTest substitutes those values in directly for me into the output. So I know right away, oh, duh, these are not what I expected, or maybe this wasn't what I expected. Anytime assertions fail, meaning assertions have a false condition here, Python raises an assertion error. Another interesting thing is assert is not necessarily a PyTest thing. It is a Python thing. Assert is a command in the Python language. It's a reserved word, so you can use it anywhere. But PyTest just uses the basic assert command from the language to make things concise, simple, Pythonic. So anyway, we have that assertion error. We have the test case failure. And then we'll even see it spilled out here. This is just more of a printout explaining what failed. So you can see PyTest is really helpful, not just for passing tests, which just kind of blip and then move on, but failing tests, it gives you a lot of rich information just out of the box. You could even use different options to get more stuff. So let's go back and fix this. We know 1 plus 2 should be 3. If we run our test case now that we've cleaned it up, we should see everything passing. Cool. Alrighty. Let's do some more interesting test cases here. So let's try to do a divide by 0. So does anybody know what happens in Python when you try to divide by 0? It should raise a 0 division error as an exception. If I were to just leave this as it is, this will raise that 0 division exception or 0 division error. It will be raised up to the level of the test case being run by PyTest. What PyTest should do is it should catch that, dunk it as a failure, and then move on to any other tests it might have. I can show that by running PyTest again. Oops. So in this case, we see F. We see that there was a 0 division error on this particular command, and that this wasn't an assertion error because there was no assertion done. It was a 0 division error. So this is to note that in PyTest, even if you have a rogue exception leak out, PyTest, the framework, will still catch it and keep all of your other tests safe. That's what we mean when we say tests are independent. They should not affect other tests. And good test frameworks have built-in features like this to help with that. So you might now be thinking, okay, well, in this case, it's expected to raise a zero division error. How do we assert that it has done that? You might think, well, maybe I could wrap it in a try except, and then just make sure catch. Try except. Oh gosh, what's happening? Yeah, you could try to do like a try except here. Try except expression, yeah. Oh my gosh, I'm sorry. The fun of live coding, getting confused by your own editor. There we go, that's what I'm looking for. And you could do something like assert true, and this is kind of like, oops. And up here, you could do something like assert false, but this is really, really janky. If we want to cleanly handle exceptions in PyTest, PyTest offers us something pretty helpful. It offers us a thing called pytest.raises. What I need to do is I'll need to import the pytest module at the top of my test module. And then in here, instead of doing all this kind of wonky stuff, what I want to do is say with pytest raises zero division error as whatever my exception is. Then I can do the expression that is supposed to trigger whatever this exception is. And so PyTest will accept this and say, okay, when I run this, if I get an exception that matches this, cool, I'm good, keep going. If I don't, let's say there's no exception or the exception is of a different type, then dunk a failure and abort and call this test case failed. Furthermore, you can make assertions based on the exception itself, such as the message. I could say a further assertion, not only is the exception thrown, but assert division by zero is in the string of the exceptions value. So this is the correct way to handle verifying that exceptions happen in PyTest. This will get the job done, but it's not very Pythonic and it's not very PyTest-like. So I'll delete that for now. We run this test now. Let's see what happens. Cool. So we're back up to all passing tests. So even though we had a test case, throw an exception internally, PyTest had the mechanisms to catch it, verify it was good, and keep going. Alrighty. Let's add one more test case here before we change gears a little bit. There may be times where you want to run a bunch of different input combos on a test case. For example, let's try multiplication. Test multiplication. Let's say I have A equals 2, B equals 3, or A times B equals. Let's do this. Let's say I want to test something, like this, where I have another operator, I want to test some sort of condition on it. But let's say instead of just using one set of inputs, what if I want to test something like 1 times 1, or 10 times 9, or -3 times 8? You could duplicate this test case, something like this. But we also like the principle of don't repeat yourself, or the dry principle. If we do this, this will create a lot of duplicate code. It will add up tons and tons of lines to our test cases. It's very, very common in test automation that you have a lot of duplicate code because you have a lot of duplicate operations. Duplicate code is code cancer. Why? Because if you copy, paste, and paste, and paste, and paste, you're spreading out these problems all over your code base. Anytime you want to refactor, it's very hard because you have to refactor here, and here, and here, and here, and here. So it's a great challenge when writing good test automation to apply the don't repeat yourself principle. If we want to have multiple combos of inputs, pytest provides a way to do that as well. It's called pytest mark parameterize. What we can do is we can specify a set of parameters to put into this test case procedure, and pytest will essentially crank through all of them. Pytest mark parameterize has two main inputs. The first thing we want to do is we want to specify names for arguments to push into the test case function. I'm going to specify A, B, and C. In the test case function signature, we also specify those arguments. Whatever here should basically match what's ever here. What pytest will do is it will inject values for these by name. So I can delete these here from being hard-coded. Second part of the parameterized piece is now we have to provide sets of inputs for these variables. And we provide them as a list. So I'm going to make a list of tuples. So our original case was A equals 2, B equals 3, and C equals 6. I could also have 1, 1, 1. Or let's say 5, 0, 0. And let's say -3, 4, and -12. Each one of these represents an input combination. So in this case, this test case will be run 4 times, one for each row. Pytest mark parameterize is really nice because we get to maximize our code. We should also be thinking in terms of equivalence classes for the values we try to push through a test case. For example, some of the equivalence classes I could denote here are just basic positive multiplication, identity, multiply by 0, multiply by a negative number, right? We don't want to have excess combos because that adds to our, not only our burden of the code to maintain, but also the test execution runtime. But we also, nevertheless, we want to make sure that we have the interesting cases, the edge cases, that we cover all of our main bases. So that's why this is a really, really helpful thing. So if I run the tests now, it should be 7 total. And everything is still passing. Cool. So, pardon me. These are just some basic unit tests, right? They're not even calling functions. They're just calling basic Python expressions. Let's do something a little more interesting. I wanted to show these examples just to show the basic mechanics of how the PyTest framework works. Let's do just a few more unit tests, but instead let's use a class to test. So I'm going to create a new package, actually. I'm going to call it, top level. I'm going to call it stuff. I'm going to have a package full of stuff. And here I'm going to make a dunder init. And I'm going to also add a Python module called accumulator. What I want to do is I just want to add a very, very basic class that I can have some methods to do some testing. So if I have an accumulator class, let's add a dunder init. And let's say I want this to have a count. And let's say I want the count to default to 0, and I'm going to initialize the count. And I'm going to add a method called def add, which we're going to add values to that accumulator. Nothing terribly fancy here. All this class does is it stores some sort of count. I can initialize that count to be whatever value I want, and I can add however many more things I want to my accumulated value. I put it in a package called stuff so I can reference it elsewhere in my project. And so now let's make some tests, some unit tests for this accumulator. I'm going to create a separate Python module, test accumulator.py. And in here, I need to say, I want to import my accumulator class if I want to do testing on it. So I say from stuff.accumulator import accumulator. Cool. Notice how I didn't put that package underneath my tests package. The reason why is because if this is what my quote unquote product code is, this is the thing under the test directory, then you should still be able to deploy to production and be okay. So let's write some unit tests for the accumulator. Now, if I wanted to say something like def test accumulator init with, let's say I wanted to test what that initial value is for my accumulator. So I could say something like A equals accumulator. That will initialize my class. And then I could say assert, asset assert, a.count should be what? Well, we expected that to be 0 based on default values. I could also run another test. Let's say def test accumulator add 1. And again, I'd say, okay, initialize my accumulator. And then say a.add. We'll just stick with the default. And then now we would expect a.count to equal 1 because we've added 1 to it. And I could also have one more interesting thing, test accumulator add 3. Again, a accumulator initialize, oh my God, I'm sorry, I'm used to C#. That's what the semicolons are there. A.add 3. I could say assert a.count would now equal 3. We could do tons more testing here, but for the sake of example, I think this is sufficient to show here's ways in which we could test a class, not just a set of expressions or even a function call, but actually testing a class. Let's run these tests and see what happens now with our pytest banner. So we see now we're up to 10 tests total. We also see that pytest separates by module the test cases that we've run. We see 3 from the accumulator class and we see 7 from the math class. That's cool, awesome. What if I only wanted to run tests for the accumulator and not the math tests? We can do that using pytest's command line options. If I don't specify a path, pytest will find everything from the current directory down. But I could specify test accumulator. And by providing a path to the module, here we can see on a second run, pytest only discovered and ran the tests from that module. So here, only 3 ran and 3 tests passed. That may be advantageous if you are doing reruns of some tests, like you found something failed, and you don't want to rerun the entire suite. You just kind of want to pinprick and laser point to get to where the failure was. You can use paths. You can also use tags. You can use, I think, even directly down to the test case name, though that syntax can get a little bit hairy. So let's come back here because there's actually room for improvement in these test cases we wrote. If you remember what I said just a few moments ago, I said we like to apply the don't repeat yourself principle. However, we've repeated ourselves. The object initialization for the accumulator is essentially duplicate code. For this trivial example, it's not that big of a deal because, I mean, it's small. But in practice, what you'll most likely find is that when you have to construct objects for testing, there's a lot of stuff you might have to put in here. And so there might also be multiple steps in order to set up or create or initialize a particular object. that you would have to do over and over again. PyTest provides a better way of doing that. Anytime you want to have shared setup or cleanup, we want to use what we call a PyTest fixture. If you're familiar with other test case frameworks like unit test or any of the X units like JUnit or NUnit, other languages, you'll know that you have setup and cleanup methods inside of your test case classes. Since PyTest doesn't have test case classes, it has test functions, we need separate functions in order to handle our setup and cleanup. And that's where fixtures come in to help us. So if I want to use fixtures, I have to import the PyTest module again. And what I can do is I can say, I want to create a function that will do my initialization of my accumulator. So let's call it accum for now. We want to decorate this function with pytest.fixture. Oh my gosh, there we go. Pytest.fixture. By putting this decorator on, we're saying, hey, this is a special function for PyTest. What we want the fixture to do is create this object right here. We want to create a new accumulator and return it for use. So I can say return accumulator. And for the case of this example, we can just leave it as the default input. So now what we can do is instead of calling this initialization redundantly, I can have each test case called a fixture. To call a fixture, what I do is in my test case function, I declare the fixture by name in the argument list. Kind of like how we did for injecting our parameters in the math test. Anytime PyTest comes to a test case function, it discovers and it sees, oh, I have an argument name. It'll look to see if there's an available fixture of the same name. If there is, what PyTest does is says, aha, I have a fixture. Before this test case runs, I'm going to call this fixture. And whatever the fixture returns, I'm going to inject into the function call here. Not only is this a setup routine, this is dependency injection. It's really cool. And so I no longer need this call here. Instead, accum now is an object that references the returned value from the fixture of the same name. So I can do this. Let's refactor our code. Boom. Sweet. So we have a fixture now, and we've refactored our tests to use that fixture. And I can prove this works by rerunning. I run the accumulator test again, and it all still passes. Cool. Fixtures are lit. I'm not going to lie. Fixtures make PyTest one of the best test frameworks in any language, in my opinion. The problem with XUnit style frameworks is that when you have your setup and cleanup methods locked inside of test case classes, that means that they can't be used outside those test case classes. And you also potentially enforce a nasty inheritance chain. In PyTest with fixtures, these things are very reusable. I can separate the concern of the test case from the test setup. I could have multiple fixtures called by individual test cases. I could have fixtures called by some and not called by others. If I wanted to have a different kind of accumulator, I could make accumulator 2. And let's say that initializes to a count of 2. And I could use that in other tests. Fixtures are very, very shareable, right? You can use them outside this module. So let's say I wanted to use them outside the module. What I want to do is I want to create a different module under my tests directory. It's called conftest.py. Conftest.py is a special PyTest module. The name matters. I didn't just pull this out of my butt. This is an official PyTest thing. Anything you put in a conftest.py module will be shared by other modules and accessible by other modules using PyTest within the same level of the hierarchy, the same directory and any subdirectories from here. So what I could do is I could wholesale move this out and drop it into here. Of course, I'll need my Oops, I'll need my import statements. But here, now I've had my fixture function in an entirely separate module from the test accumulator function. Or, sorry, I have the fixture function in a separate module from the test accumulator module. But the tests are still going to have that reference by name. It'll still work. Oops. Damn. So if you want to share test fixtures between multiple test cases, best practice is put them in a module, or put them in the conftest.py module. Alrighty. Also, if you want to learn more about some advanced fixture stuff, highly recommend the pytest docs. You can do things like setting scope. You only want a fixture to run one time for the entire test suite versus for each test case. You can set a scope of session. Usually as a best practice, by default, you want your fixtures to run per test case, as they would be here. But just there's all sorts of fun stuff you can do. They're even out-of-the-box fixtures, right? Things like setting up temporary directories, accessing test requests. It's pretty rich. Cool. So let's come back and look at running our tests again. We know at this point we have, oops, sorry about that. We have 10 different test cases, and they're all unit test level. I'll run them again, show that they all still work together. Maybe wondering, what are some other interesting things I can do? Because this little banner is very helpful and nice, but it's not like a ton of information, right? What if I wanted to get something like code coverage out of this? PyTest has a module for that. Let me clear it, bring it to the top. If I want to do code coverage with PyTest, all I have to do is install the pytest cov module. Underneath the covers, this will use coverage.py. So here, if I'm installing it, just give it just a minute here. There we go. Okay, cool. Oops. All right. So if we want to use code coverage, what we can say is when we invoke our test command to run, we use the --cov option. Oh, did I screw that up? Yep, there we go. Whoa, okay, that was huge. Okay, so yes, if you want to run with code coverage, you run with the --cov option. It'll still show the same banner as it did before, but then it'll show you all the statistics about how code coverage was handled. Now, it's a little bit hard to see. The reason why this is so spilled out is because it actually looked for code coverage in my virtual environments. So that's no bueno. Let me try that again. If I give it a path, if I explicitly tell it to look in my tests path, let's try it again. That should be a little bit cleaner. That's much better. Okay. Live coding, you surprise yourself sometimes. So if you specify the path, it'll only do code coverage within that path. I really should have done code coverage for the stuff package. So let's try that again. There we go. That's a little better. So if we look at the banner, as again, I said, it's all the same, but it'll also add this coverage piece to your output. And it'll show all the files in the path that you specified. So in this case, since I gave it the stuff path, we're looking for code coverage in stuff accumulator.py. And we can see the percentage of statements that are covered and the number of statements that we're missing. And it tallies it up for you here. I believe there's some slightly more advanced options with code coverage than just what you see here. But you can play around with it, look up the docs and such, and it adds on to PyTest as a plugin. Another plugin you may be interested in would be here. PyTest HTML. If you want pretty HTML reports instead of just the PyTest banners that print out, you can use the PyTest HTML package. Boom, boom. Okay, so if we wanted to print an HTML report, we could say with our pytest command, --HTML, and give it a file name. So now when we run, you'll see added to the banner, generated HTML file, user, and okay, that's me, pytest report. So it should be in this directory. If I check this out, you can see it's all HTML, but we don't want to see it like that. We can open it up in Chrome or Firefox or Safari, and we should see something nice and pretty. Typically, this is the kind of thing you'd want to show in CI or send to your manager or something. But you can see it. It's just a more visual way to see how everything spills out. So that's really cool. Both of those things I just showed you are what we call PyTest plugins. PyTest plugins. PyTest has a myriad of plugins. Basically, another reason why I love PyTest is because it has this plugin framework, right? You can extend PyTest to do almost anything you want. The basics are there, and you can just add on, whether that's special kinds of checks or integrations with other frameworks, or even new kinds of ways to write tests. So pytest-cov and pytest-html are very common ones. You can go to the PyTest docs page. They have plugins for things like Django. Xdist is used for parallel testing. PyTest BDD is to write Gherkin-style tests. I love BDD. You can check for PEP8. I mean, it's all there. And you can even write your own plugins. It's not like you have to be a wizard. Technically, anything that you put into the conftest.py module is de facto a plugin. But so technically, this fixture is a plugin. But usually when we say plugin, we typically mean a package of stuff that adds to the PyTest framework. So I could speak worlds more about PyTest. There's a lot in this framework. I hope what I've shown today in terms of unit tests is very valuable. If you want to learn more about PyTest, a few things I can recommend. First of all, like I said, the doc page. There are a couple books I can recommend. Python Testing PyTest by Brian Ocken. This book is wonderful. I know Brian, I've read the book. Very, very helpful. He shows how to use all the different facets of the PyTest framework. Another book, Getting Started with PyTest, or PyTest, what is it called? PyTest Quick Start Guide. Here we go. PyTest Quick Start Guide by Bruno Oliveira. Bruno was one of the PyTest core developers. He wrote a very, very helpful getting started guide with PyTest. This one I think is a little bit better for those who are kind of new to testing as well as new to PyTest. And so it's much more like a tutorial setup where it's like you read a lot of information and you kind of iterate as you go, which is, I mean, both books are really good. If you want to learn how to do something more than unit testing, if you want to do, say, web UI testing, today, Test Automation University just released a new course that I developed called Selenium WebDriver with Python. This will show you how to interact with a web browser using Selenium WebDriver, actually sending clicks and sending text, and using Python with PyTest to automate tests around that. So definitely give this tutorial a check if you want to learn how to do something more than unit tests. You could also do things like REST API tests using the request module or Tavern maybe. But I mean, PyTest is not just a unit test framework. It is also An integration test framework is also an end-to-end test framework. It is a general purpose test automation framework. So yeah, I hope that was really helpful. If you want to follow me, you can follow me on Twitter at Automation Panda. You can also check out my blog at automationpanda.com. I've got a lot of stuff on testing and Python, and good stuff in general.
Awesome. Thanks so much, Andy. Can people in the chat please give Andy a round of applause? That was very, very useful information. Also, we do have some questions. So if you do have questions in those of us that are watching, please ask them in the chat. We will queue them up and the speaker will get to them. So actually, I'm going to ask my question first because I think it's a little bit easier this way. So say you work in an organization that is just starting to implement testing and you're trying to convince others to take up the testing mantle. How do you go about doing that? What's the business value of testing?
Oh, man. So that's a great challenge because not everyone sees the value. Well, the value I always pitch for testing is, like I said when I opened, it's identifying badness as well as verifying goodness, right? The idea that if you write a test, this is an artifact of your software development process. So you should treat it well. You shouldn't treat it like crap. But it's there to protect you. It's there to be your insurance policy. It's there to be a mitigation, or it's there to mitigate risk. And so when you write a test, what you're saying is, I think it should work this way. Not I think, I know it should work this way. This is kind of like almost like requirement level. This is what it has to be. And so when you take that tax of time as you go and build up your test suite, the further out you go with it, the more tests you have, the more protection you have. I think people's eyes really don't open at first. They kind of see it as, oh, well, this is like an extra activity. It's a tax on my time. I'm not sure I'm seeing value. But if you stick with it, you'll eventually hit a point of critical mass where your tests inevitably start catching things. And then people have bing bong, oh, light bulb, like, got it. Oh, this really is valuable because I made a change. I ran the tests and it caught a failure before I deployed it. Right. So that's, I think, where you can have the selling point with trying to convince others that tests are really valuable.
Yeah, that's a fantastic answer. We actually have some questions from our audience. Some folks have been starting to implement testing at work. Some of the people at their job are picking up PyTest. Others have decided on unit test. Can you go over some of the pros and cons of going through unit test or the PyTest framework?
Absolutely. I have very strong opinions on this. So advantages of unit test. Unit test is part of the Python standard library. You don't need to pip install to get it. It's there out of the box. It follows the XUnit style framework. So if you have people coming from another language like Java using JUnit or C# using NUnit or any language that has an XUnit style framework, they're going to intuitively know how to use unit test off the shelf. So you don't need to do a whole lot of retraining. They say, oh, so I have a test class. Inside of there, I have methods that each represent a test case, and I have set up and cleanup methods that do. I know this, right? There's a sense of familiarity there. The cons of unit test are that, first of all, you're locked into that class structure. In my opinion, I don't think a class is necessarily the best way to encapsulate the entity of a test case. I think the XUnit style way of encapsulating test cases like that is simply an artifact of the time in the 70s and 80s where object-oriented programming was the shiny new thing and everything got shoehorned into the structure of a class. Hot take it for what it is. I'm not saying that's right or wrong. I'm saying that's my opinion on my perspective of why XUnit style test cases are the way they are. And really, PyTest is the only one that's doing something a little bit different in this vein, where a test case is truly a function, more functional-esque type programming where functions are first-order values. We try to keep things simple. And so the advantage of PyTest, I think, in that case, is that I think functions are simpler than classes. I don't think classes are necessarily complicated or too hard for people, but I think functions are simply simpler. Also, with PyTest, you get those fixtures, which makes setup and cleanup much more reusable. So you're not limiting your your setup and cleanup to be inside of one particular test case class, then hum and ha, oh, well, I need it over here. Well, do I need to make like some sort of new module to have all this setup cleanup logic? Fixture, boom, done. Put it in conf.test.py and share it everywhere. And then you can use dependency injection with that fixture, and you have controls over the scope, and you can have some test cases using multiple fixtures, some test cases not using fixtures. And another thing I didn't share is that fixtures are not only set up a cleanup. We saw a fixture with a return statement. If you have a fixture with a yield statement, it becomes a generator. Iteration 1 is the setup, iteration 2 is the cleanup. So you have setup and cleanup paired together, which is typically more sensible for what you want to do. Third reason for why I think PyTest is better than unit test, those plugins. PyTest is easily extendable. Unit test doesn't have that. And so like you can put things in unit test, you can use it. It's a great framework. It's simple, it's easy outside of the box. But PyTest just gives you so much more firepower. So with all that to say, I think PyTest is categorically better than unit test. Unless I were forced to otherwise, I would always use PyTest. I would not have a case for using unit test, unless for some reason I'm not allowed to pip install PyTest.
Yeah, it's I've always found that the inheritance hierarchy that unit tests are just like forces people to take on, it makes your test really hard to follow. And then you have test fixtures that are changing things in tests that don't have anything to do with those fixtures. Yeah, I think we're all there. So yeah, PyTest has changed my life in so many ways. Fixtures are my favorite thing.
Yes.
We actually had a question from Jay about asynchronous code testing. Do you have any books or recommendations on doing things like that?
Oh gosh, yeah, the async thing has taken Python by storm. In fact, I've been to so many Python conferences, they're all blurring together. I know there are several very good conference talks on testing with async. I can't begin to remember where and what conference. Past 2 years, if you Google Python, PyTest, async, you'll find something.
I think PyCascades just had one back in February. I'll post a link. Check our YouTube comments down below after this video to find out where to find that talk.
Yeah, and there is a PyTest async AIO plugin. So if you just Google pytest-async IO, you'll find it. It's part of the PyTest Dev project in GitHub, so it's like officially sanctioned and all that by the project. That's probably the best place to go to kind of learn on your own, I would guess.
Awesome. We got one more question. Other than pytest-cov, are there any other plugins you use to determine how good your tests are in terms of quality?
Me personally, no, but I am positive there's something good out there.
Cool. Awesome. So I just have one last question. Do you have any action items, calls to action for our community?
Gosh, yes. Treat each other well, especially during COVID times, but also during non-COVID times. Get plugged into your local community as well as your international community. Get part of local meetups like this, go to conferences, get to know each other, and just be awesome. And write more tests. Write more tests.
Write more tests. Words to live by. Well, thanks so much, Andy, for joining us. I'm really glad you get to experience what Chippy's all about.
Thanks for inviting me. It's been a blast.
So for those joining in, so my name is Ali Sivji. I am your host for tonight's event. We just had Andrew Knight talking about getting started testing with PyTest. We're going to take a 5-minute break, and then Josh Dolitsky is going to come back and talk about CloudFormation and infrastructure as code. We do have a discussion question for tonight. Let me just get my screen shared. So what is your favorite non-Python programming language? I know everybody's favorite programming language is Python. I mean, you're at a Chippy event. Why wouldn't it be Python? But other than Python, what other languages do you like to use? Andy mentioned that he liked to do Haskell. I actually had a friend text me. He's like, Haskell, shout out, man. That's awesome. So what languages do you like to use? But before I go, if you're liking this content, be sure to click the like button, subscribe to us, hit that bell notification, find out when new videos are being posted or when we're going to go live with more live streams. We'll be back in 5 minutes. Thanks, everybody. Hey everybody, welcome back to the Chicago Python WebDev / DevOps Special Interest Group live stream. My name is Ali Sivji. For those of you who are just joining us, we just had our first speaker go, Andrew Knight, talking about pytest and getting started testing. In a few minutes, we're going to have Josh Dolitsky come on and talk about infrastructure as code with AWS CloudFormation. We do have a discussion question of tonight. What's your favorite non-Python programming language? So let's start going through the comments. We have some folks doing Rust for embedded microchip programming. That's really, really cool. Scheme, another solid choice. Oh, I really like this one. Encode. I don't know if anybody's started up doing Advent of Code. During the Advent calendar season, just like from the 1st of December to the 25th, they release one coding challenge a day on adventofcode.com, and folks compete. This year, one of the problems featured in Encode, so that was a lot of fun. So just a throwback to that. Let's see what else. I think I saw somebody say C. I mean, if you're doing Python, you're doing C. That makes a lot of sense. Yeah, you got plain old C. Some folks like JS, some like Go. Yeah, I would say my favorite non-Python language would probably be, would it be a cop-out to say like Python? Let me know in the comments what you think, if that's a cop-out or not. All right, Josh, we're going to just bring him on right now. Hey, Josh, welcome to Chicago Python.
Hello, can you hear me all right?
Yeah, I can. Do you mind introducing yourself to our audience?
Of course. My name is Josh Dolitsky. I am a software developer and I'm here in Chicago. I am focused on DevOps and automation and cloud type stuff. But I do have a background writing Python backend type stuff. And big fan of the Chippy user group, and I'm happy to be here.
Awesome. Yeah, I know you don't use Python like as your primary language, but can you sort of just talk about your experience? Like, how did you get into back-end coding?
Yeah, I mean, I think I started, Python was actually my first programming language, and I don't know, it was mostly in an academic sense, and then from there got more into JavaScript and PHP and web development type stuff, then Ruby, then Node.js, a little time with Perl, and then now I'm mostly doing Go, which I'm a big fan of, but I won't try to convert anyone during this.
No, it's but would you say that would be your non-Python favorite language right now?
It's absolutely my favorite language. If you're interested in why, I can talk all day about it.
Awesome. I think we should have you back to talk about why Go is fantastic. But we're all sort of dealing with being sheltering in place. How have you sort of handled it personally?
Yeah, it's kind of easy to fall into working all the time, I think, with this, especially if you're in the software world. So I would say just be mindful to take some time to do normal stuff, read a book, spend time with whoever it is that you might be quarantined with if you're lucky to have someone. Call your family, call your friends, make sure that they're not getting lonely or starting to go a little nuts. But yeah, just kind of keep healthy habits as much as you can, and just realize that everyone else in Chicago, at least, and worldwide is going through similar things.
Yeah, we're all in this together. Like, I've been connecting a lot more with my friends from college who I have not talked to in a long time.
Sure.
But thanks so much for coming on. Are you ready to get started?
Absolutely. I can go ahead and share screen here.
Awesome. All right, you are up. Josh Dolitsky, please take it away.
All right, you able to see the slides all right?
Yeah, we're all good.
Great. So yeah, I'm going to talk a little bit about AWS. I'm going to talk a little bit about infrastructure, what that means. I'm not assuming too much prior knowledge about systems or infrastructure or DevOps or anything like that. So I'll spend some time making sure that all of that's defined. And then from there, going to show how you can use this interesting library called Troposphere to actually build infrastructure as code using pure Python. So I mentioned a little bit about what I do a few minutes ago, but I own a consulting company focused on DevOps, Kubernetes, cloud type things. So if you are interested in this area, please feel free to ping me in the Chippy Slack. Or if you work for a company that's looking for these types of things and need help, I'm happy to, talk business. But I'm involved. I've been involved for about the last 3 years in a lot of open source stuff related to Kubernetes and containers. Kubernetes is if you're not familiar, is a platform for running containers. And if you're wondering what's containers, if you know anything about Docker, Docker is pretty much synonymous with containers. I'm one of the maintainers of a project called Helm. Helm is a package manager, which you can think of like Brew or apt-get or Yum. That is specific to Kubernetes. So if you're installing applications into Kubernetes, Helm is sort of the de facto tool you would use to do that. And this was, I got involved. I got involved with that project a few years ago when I developed a project called Chart Museum, and that was since adopted as part of the Helm project. And like I said, I'm mostly doing Go today, but there is a very special place in my heart for Python. It's my first programming language, and I think it's the absolute ideal first language for anyone to learn. And my favorite quote, I think, is from T from the user group, which is, Python is the second best language for everything. What is, if the title of the talk had AWS in it, you may not know or be in the space to know enough what that is. What is AWS? AWS stands for Amazon Web Services. So this is the company Amazon. When you go to buy something on Amazon.com, this is the same company. I heard a statistic semi-recently that Amazon Web Services, the revenue that they're actually getting from this has surpassed what Amazon has made on Amazon.com, which is pretty unbelievable. And when people talk about the cloud, a lot of times they're referring to Amazon, or they're referring to Google's cloud, or Microsoft's cloud is called Azure. And there's several other kind of smaller ones, DigitalOcean. But I would venture to say 75, 90% of the time, we're talking about AWS when you talk about the cloud. So Amazon Web Services, to recap, it's just one of many of the cloud providers that are out there. And what is a cloud provider? It's a company that you pay to run your code and the backing services that support your code. It's very widely used. Like, it's probably more widely used than you think. Like, if you're gonna, after this session, go watch something on Netflix. Netflix's entire infrastructure runs on top of AWS. And you have to think about the scale of that as they're serving video content all over the world 24/7, 365. And on that point, Amazon does have physical data centers, places where they have thousands and thousands of servers scattered all over the US and scattered all over the world. So if you're deploying an application that is for, I don't know, a soccer team in Ireland, you're going to probably put your servers in Ireland. And there's also ways where you can do interesting things where you deploy a version of your code in different locations, and based on where you're requesting the website, it will use the server that's closest to you. And one of the things that I think a lot of cloud providers have this, but I think one of the things that sets AWS apart is that they're very much API first, meaning that the APIs to do cloud stuff in Amazon are built in such a way where it's very programmable. You can write a client. They're very well documented. You could write a client to work with this API. And as far as I understand, the API, when they're building new services, they're actually working from the API up. So the actual console, the UI that you can click around in is sort of secondary to the API. So infrastructure, what are we talking about when we say AWS infrastructure? Are we talking about roads and the industrial infrastructure, you know, of the city of Chicago and trains and things like that? No, we're not talking about that. We're talking about your servers and anything else that provides, that backs that application up. So on the right side of this diagram, you see there's a database server. So think about MySQL, MongoDB, things like that. DB caching servers. So if you've ever used Redis or Memcached. And then on the left, like load balancers are things that will spread traffic. So if you have a heavily used website, if you want to spread traffic across, let's say, 10 different servers running a replica of your code, a load balancer does that. And if you're just watching this and you know Python and you know how to write a Python web server, if you've used Flask or something, in this diagram, this is actually the location that your code will run, whether it's you know, running just with a daemon or as a container. Ultimately, it's on an application server somewhere. But there is a lot of logistics to how you're routing requests when someone goes to yourcompany.com and getting the request all the way there and back. So we're talking about, when we're talking about infrastructure, we're talking about things that run your application and the things that support it. It's a general term for parts of your product of your software product that isn't the actual code. If your application uses a database, that's infrastructure. If it uses a cache, that's infrastructure. And I think this is a little bit debatable, but even if you're familiar with serverless and Lambda and things like that, you could even consider the function as a service, like the Lambda function, as infrastructure itself. So with Amazon, how are you going to provision the infrastructure? Well, I said that they have these great APIs. So really all you're doing is you're going to make an API request over HTTP to request that they provision a service on your behalf, and then they charge your credit card and that it's done. And the easiest way that you can do this is by logging into the Amazon web console and click around. So here's an example. This is a screenshot of when you're within the web console. This is sort of the portal that they have where if you want to launch an instance, and you can see they provide you different types of instances. They have these different sort of tiers, and they have small ones with just one CPU up to a ton, right? So, and you're the way that they sort of, their business model is the larger, typically the larger, more, the stronger the instance, the more CPU memory, throughput, et cetera, the more expensive they are. So, and what they do is it's different than if you sign up for like GoDaddy or something like that, where you're paying like monthly, maybe $20 a month for this WordPress site. I don't know. With Amazon, it's very specific, like you're paying fractions of a penny per hour, which actually, you know, if you think about the number of hours in a month, could end up being hundreds, if not thousands of dollars. And, you know, bigger companies have pretty large AWS bills in the tens or even hundreds of thousands of dollars per month. So what's wrong with going to the AWS console and clicking around until you have all of the services or servers that you want? There's nothing really wrong with it. In fact, if you're provisioning maybe one server, something like that, it's not so bad. The problem is that one click quickly turns into many clicks. Let's say you're providing 5 different services. There might be, you know, 3 different screens per service while you're provisioning these things. And on top of it, for everything that you provision, you are on the hook to pay for, right? There is actually, if you're interested in just trying out AWS, I think you do need to put a credit card in, but there's something called the free tier. And you can actually, if you're using small enough instances, not pay for a certain amount of time. But I'm not here to sell you Amazon. But beyond that, there's over 100 different services located inside of Amazon. So you better hope that you remembered all of the things that you've provisioned. Otherwise, you're going to end up paying for things that you completely forgot about. And it's complicated by the fact that you can create a server in this region and it doesn't show itself. It doesn't show itself in the portal because you have to transfer regions to switch between portals. So if at one point you went and launched an instance in India, I'm not checking my India region every day, and maybe that thing stays running and you end up with a bill. And then on top of it, like some of these services require that you've provisioned some things ahead of time. So you get to the screen and you go to create something and it says, well, what's the security group you want to use? What's XYZ that you want to use? And so you end up jumping through all these hoops to get all these things deployed in such a way that it's you know, you're just trying to get your server up and you're not really thinking about these different pieces to the point where if you wanted to actually remove everything, you need to remove them in the same order that they're created in that dependency tree. So it can get a little bit hairy like that. And then this clicking things, especially for a productionized environment, is sort of anti-DevOps. And DevOps is essentially, you know, there's sort of a lot of confusion and disagreement about really what DevOps means, but this is my own definition, is that it's the improvement and automation of everything between the time that you make a change and commit it into Git or GitHub, and between that occurrence and your code running in production. So like Andrew was showing with pytest, that's could be considered DevOps. You're taking code that's been checked into GitHub, running tests against it. You might build a container or build a server image, an AMI, and publish that somewhere and then deploy your thing. That's sort of DevOps. So if you're clicking around and creating servers, you're breaking many rules of DevOps, where all of this should be automated. And I think that I heard this quote somewhere, but now I'm starting to think that maybe I made it up, but it reflects a lot of different things that I've read. But the maturity of your company's DevOps can be measured by how quickly you could completely rebuild your production environment from source code alone. So let's say you have your Amazon account or your server room just completely dies in a fire, burned to the ground, and you have nothing but your source code on a USB stick. Doomsday scenario. But what would it take for you to get your website back up exactly like it was before the fire started? And that is why we need to use something called infrastructure as code, which I'll talk about on the next slide. So how can we do DevOps on AWS? So there's sort of three primary options. If you know of anything else, please say so in the chat. Or if your company's using something else, please say so. The most general one is AWS CloudFormation, which is what I'm going to talk about tonight. And what AWS CloudFormation is a way to define all of your AWS resources in one JSON file. And what's great about that is that you could deploy everything and undeploy everything in one fell swoop or all at once. And that really solves the clicking around issue, right? Then there's also Terraform, which is a great tool. It's made by a company called HashiCorp. If you're familiar with Consul, CONSUL, or Vault, they're the same people that make those tools. And then Amazon provides a command line interface. It's actually written in Python. And depending on how simple your situation is, and I actually use this more times than not, is just writing a simple bash script that calls the Amazon CLI and deploys it. You just have to make sure that you're the inverse of that script that undeploys a thing is doing all the right things, which is what makes CloudFormation and Terraform sort of the better long-term option. So CloudFormation is Amazon's official solution for infrastructure as code. So infrastructure as code, really all that it means is that you're storing and versioning your configuration files for your infrastructure exactly the same way as you would version and store your Python code in a Git repo. So it's if you understand why you're using Git and why you're using GitHub, it's exactly the same concept, exactly the same value add, but for infrastructure and not for your source code. So an example of this, if you're super mature with this, you could have, let's say, a developer on your team was tasked with adding caching support to your application. So like support for Redis, for example. If you're not familiar with Redis or caching, it's just a way that the state of your application is stored even if your server goes down, or if you're running multiple servers, they could share state between one another. It's for speed and reliability purposes. But let's say you're trying to add that support in your Python code. So you would import some Redis library. And you would from your Python code, make a connection to a Redis instance and cache, store, and retrieve stuff from the cache. But in your production environment, you would still need to create a Redis instance. And so what you can do is in one single pull request, submit the support for Redis, as well as the actual production infrastructure of the Redis itself in a single commit. And it's just so much more reproducible than clicking around in the Amazon console and hoping to remember what you've done. There's obviously hiccups, here and there if like AWS has updated something, or you have the wrong version of the Amazon CLI. But I would say more often than not, it's pretty reliable over long periods of times, like over years. So this is sort of an example of the beginning of a CloudFormation JSON. And you may be looking at this and thinking, that doesn't look like something I want to touch or work with, right? So you may be asking, I don't like to edit 5,000 plus line JSON files. They're not always this large, but if you have some pretty advanced infrastructure, they can get quite large, and you better hope that you have all the right quotes and the right commas and the right curly braces in all the right places. And I agree, this is not a way to live your life. And so there is a way that this can be made easier, and that is that you can use Python. You can use Python to generate that JSON using a really cool library called Troposphere. So I am going to switch out and do a demo here. If you want to follow along, I have a public repo here, which I will throw into the YouTube chat as well. But all the source code I'm about to show, if you want to follow along in your browser, if that's easier for you, you can go here and yeah, everything that I'm going to show in my editor is right here. So let's take a look at some of the files I have going on here. So this is the CloudFormation JSON that we're going to build. It's not 5,000 lines, but let's see how many. 90 lines, not so bad. All this does, it's as simple as it gets. And to be truthful, it's a really bad example of why you would use CloudFormation, but I wanted to show a palatable example with this. So it has all these custom fields, mappings that you can reference later in the file, region map. If I look elsewhere in the file for region map, you can see it's trying to. They have all these special JSON fields where you can actually go fetch things from other parts in the file. It's actually pretty brilliant and well made, but again, like this is not something you really want to edit by hand, although at one of my jobs, that is actually what I did. So it has the concept of outputs. So once you've created your CloudFormation stack, it's called, it will tell you all these different things about your stack. So for example, what's important to us, the public IP address. So this is going to deploy a server, and it will spit out the public IP of that public IP address of that, so that you can from a script or something pull that out and pass that along somewhere. Maybe send it to a Slack channel or whatever you need to do. And then finally, resources. These are the actual things that you're going to, the services you're going to deploy on Amazon Web Services. And right here, all we have is EC2 instance section defined, and all we're doing is creating a single instance of this size, and this size has a certain CPU and memory associated with it, and a certain cost associated with it. Key name Chippy. This is a SSH key if I wanted to get into that instance, and all sorts of other fields that are probably not even defined here. It's very customizable. Amazon has a lot of documentation on how to use raw CloudFormation. But let's take a look at Troposphere really quick. So Troposphere is pretty neat. What it allows you to do is import a few things here. So import Troposphere EC2 as EC2. EC2 is on Amazon just servers. It's the most basic unit from Amazon Web Services. But like, this is as simple as it gets, right? Like, you could start a template, a JSON, a CloudFormation template. Let me zoom just a little bit more. Create a new instance using the EC2 library. Set the image ID on it. AMI are sort of like base images. So there's all sorts of AMIs. You can get ones for using Ubuntu or using Fedora or whatever your Linux distribution of choice is, and the type of it. And then you add the resource to the template, and then it provides this to JSON, which will spit it out to standard out, or it will return a string, and then you can print it to standard out of your template. So from there, then you could take this JSON, and for example, if you go to Amazon, this is the Amazon console. If I were to be a clicky type person, I could press create and walk through here and say upload a template file, and put that JSON file here. We're not going to do that because, again, anti-DevOps. But what we will do is write a tiny script. So I have and this is all in that repo, build CloudFormation JSON.py. So I'm importing all of this stuff from Troposphere. And this actually, in full transparency, is just an example here that I've modified a little bit. So if you go to the Troposphere repo, it's under Cloud Tools Troposphere. I don't know what company this is associated with. I think it's actually truly an independent project. But if you go to the examples folder in here, you can see all these different examples for how to deploy or how to build CloudFormation template for all these different Amazon services. So DynamoDB, which is similar to MongoDB. ELB is an elastic load balancer. All sorts of stuff here. If you wanted to write a Lambda that deployed your Python code, you could look at that. But anyway, back to our script here. So I'm going to take an environment variable. This was part of the modifications I made, called message. And the hope here, I'm having a few issues getting this to work, so I really hope it works for the demo. But take a message from the environment that you want a web server to say back to you when you run the web server. So creating a template, this is how you start a CloudFormation template with Troposphere. I'm adding a mapping, so this is what that is. And keep in mind, this JSON file we're looking at is the actual results of running this script. I'm going to create or add to the template an EC2 instance with all of these different fields. That whole thing to kind of determine the region or the correct image ID for the region. It's really interesting. I mean, so you can deploy in these different places all over the world. So if I say I want to go into US East 1, it's going to use this base image. And so this really just builds out that section that references the key value, getting the AMI key out of the object returned by passing in this region. I'm hard coding the instance type just to keep it simple. This is a key name. This was the one thing I did click and create ahead of time just for the sake of the demo. But you could actually create an EC2 key pair called Chippy prior to the EC2 instance and pass that in kind of like we do like that. The default security groups is a security group in the account that's when you create a new account that's there by default. I made one other modification. I know I'm sorry that exposes port 80 so we can run a web server and hit this instance remotely. And then user data. User data is an interesting thing in Amazon, which is when your server starts up, run this stuff. And I'm doing what seems to be, or I thought was very simple, but I'm having a few issues. But I'm making a directory called web server on the file system. I'm creating an index HTML file, which is the roots of a web server. And then I'm using this Python simple HTTP server to start a web server in the web server directory. And then this little and thing to kind of exit the script and go in the background. I think this is the source of my problems. You really want to use like a true daemon type thing to run your code. And then you can define the outputs. So these are things like the public IP. This is the really important one that we want to expose. And then all I have is a bash script. And I can just walk through really quickly. This command is the Amazon CLI. So you can install this with pip. You can pip install AWS CLI if you want to. It's creating a virtual environment and installing Troposphere, which is defined in my requirements txt. And then it's going to run this script and pipe the output to a file called CloudFormation.json, which is the first thing we looked at. And then it uses the Amazon CLI to deploy it, pointing to that JSON file with a specific stack name, which is defaulted to Chippy Love. And then once it's deployed, once this is done, it will actually hang while it's deploying. We run this describe stacks to try to extract the IP address. And if you're not familiar with JQ, awesome tool, but it basically allows you to take JSON and get things out of it in a nested way. So if you look, well, we can't look at, I don't have the output here, but this is getting the output of the IP address. A little janky, but it works. So let's go ahead and run this script. I've already all right. Let's deactivate. So let's run the script. All right, so there it is, installing Troposphere into a virtual environment. So that is right here. And now this is starting to run this command here. It's already created this JSON file or overwrote it. I should have, bad demo, I should have removed that ahead of time. But it basically piped that into this file, and then we're going to deploy it pointing to that file. If I go back to my Amazon console to the CloudFormation portal, you can see, a little too much zoom, that there is a stack here called Chippy Love, create in progress. And if you dive into it, it'll show our template. So this is the JSON file that was created by Troposphere and passed through the Amazon CLI. This should look, here's that user data that attempts to start a web server, we'll see. And it also lists all the resources. So imagine you had, like, I'll just really quick, I'll jump here. I mean, look at just the sheer number of different Amazon fraud detector. I don't know, maybe you need that. I don't know, I've never used it. But there's all sorts of these different things that that you might deploy as part of your stack. Right now, we just have an EC2 instance, which is the simplest thing. And it'll even give you links to go learn more about that thing. So if you go into here, it'll show you, this is the instance, that's the type we expected, here's its public IP. If I go back to my script, the last line is it extracts that public IP. And if I grab this and open it in the browser, crossing my fingers that the web server worked. There it is, there's our server. And now I haven't automated this, but what's really great about CloudFormation is you can actually delete the stack in one fell swoop. I don't have this in the script, I'm sorry, but you could use the Amazon CLI very easily to refer to this. You know what, let's figure it out. Probably just delete stack, yeah. So AWS Cloud Formation, delete stack, -- stack name equals Chippy Love. That was mysteriously fast. And now you see it's deleted in progress. If I try to hit my website again, you see it's hanging because if I go to my instances, it's starting to shut down and it will terminate, and I won't end up paying for it all month. So that's that for the demo. Oh, I think I stopped sharing altogether. One sec. So yeah, again, if you want to see that code in action, you should probably just go to the troposphere examples. But if you want to see specifically what we just did, github.com/bloodorangeo/python-aws-infra-demo. And again, if you or your company is struggling to figure these things out and you might need a little help, feel free to give me a ping and we can talk business. And here's my website if you want to learn more about what we do. Thank you very much. That's all I have. Thanks for having me.
Awesome. Thanks so much. Can everybody give Josh a round of applause in the chat? I'm clapping right now in my apartment. So we do have a couple of questions. So actually, I'll start with a question. If you have, say, resources already out in AWS and you want to get them into CloudFormation, is there a way you can like back it out?
No, and that's not as far as I know. And that's part of the reason why you really do want to use CloudFormation. The alternative is using, writing your own thing to do CloudFormation, like a bash script, or Troposphere, or not Troposphere, Terraform, HashiCorp Terraform, which might have more options for that. But in terms of pumping something into an existing thing, I've had a bad time with that.
Okay. Yeah, I actually do know, like, I've had some experience with Terraform, with like their Terraform import command. I was able to do it with my AWS and DigitalOcean. That was pretty cool. So there is a question by T. You actually just gave him a shout out in the talk. He's out there watching. So he's wondering, what does Troposphere support in terms of new features for CloudFormation?
That's a really good question. That might actually be one downside to Troposphere, is that you would probably wait a week or two for that to hit a new release, because they are classes, as far as I understand. They may have a way that you could create your own. To be frank, I don't use Troposphere all the time. I just thought I just think it's super cool. But again, it's just JSON. So if you import the standard JSON library in Python and inject something in there, it should work.
Awesome. And if anybody does have questions, please ask them down below. T actually had a second part to his question. I don't know if you're familiar with the CDK Python, which is like, I believe, AWS's cloud development kit. Do you have any opinions on how it compares to Troposphere?
Let me pull that up. I have not used this. It looks quite similar. No, I don't know. It might be a newer thing that I'm not aware with, and might actually be a better option. Sorry, I don't have much more to add there.
No, there's definitely a lot of options in the space. I think that's like one of the things. Like, I really enjoyed like watching you. Like, you're like, how do I use the CLI for AWS? And it's like, those are one of the things like I'm always scared of. So it's like I always enjoy watching people live code. But I think you also recently started live coding. Can you like tell folks about that? How they can like follow you on Twitch?
Yeah, thanks for that. So once the COVID stuff sort of hit, I felt a kind of call to action, sort of, at least at first. And I wanted to help people who, especially, from different industries that are really hit by this, like restaurants and bars, that if they're just, if you're just at home, not sure what to do or when the ban and everything's going to be lifted, that you could learn, start to learn some new skills in industries that aren't hit so hard, such as software development. So yeah, if you go to twitch.tv/jdolitsky, I actually have done already 2 live streams that are recorded up there. They're a little rough, but it's starting from scratch, no prior knowledge of any HTML or anything, how to do web development using nothing but like the browser and Sublime Text. So yeah, if you know anybody who's in a really bad situation and is trying to break into this field, definitely please send them my way, and I'd love to help them out. And I think for the third one, I was actually thinking of doing starting to do some backend stuff with actually Python web server.
That's awesome. It's like, it's really great to see like folks coming together, and like community is such a big part. Like I know like you're really involved, like, especially in the Kubernetes community. We actually also frequent the same open source user group like once a month and do our hackathons. Like that's always fun, always good to catch up there. There was one more question in the chat. So this is for specifically Trophosphere, if you want to talk a little bit more general, but how would you go about testing your like infrastructure as code scripts?
Yeah, I don't know if Andrew's still here. He might be better to answer that. But so at the end of the day, this is creating a JSON string. So a really simple thing you could do is write a test to send the JSON into a variable, and then parse that back into a Python dictionary or Python object using just the JSON dump or JSON load rather, and just like iterate onto some nested field and make sure it's there. That's one way you could unit test that your JSON is actually being generated simply. Or if you are into Bash like I am, I would use JQ.
Yeah, that definitely makes a lot of sense. And I think like if you really want to spend some time, you could probably like write up a little bit of like a test simulator that spins up like test infrastructure and use like CLI to sort of like make sure things are working like in a sanity check.
Yeah, and that actually that points on to, you know, CI type stuff. If you go to my repo that I shared, there's actually GitHub Actions to run all that stuff. And this is a very, you know, a real world use case of how you would do continuous deployment of your code. Awesome.
Well, thanks again. We really liked having you on and learned a lot about CloudFormation. Before we do let you go, do you have any words of wisdoms or action items for our community?
I would just say, you know, this is a crazy time, and I really miss going to the real meetup, because as much as I love the talks, I love to, you know, catch up with everyone over some pizza and that. So it's a real shame, but please stay positive, support one another. And I'm always here if you want to just talk about non-code things too. So
thank you. I really appreciate you making yourself available to our community. Can everybody give Josh one more round of applause in our chat? It's great, great having you.
Yes, thank you. Thanks for including me.
All right, man. I will hopefully see you soon at one of the open source meetups.
Yeah, hopefully.
All right, man. Take care.
All right, bye.
All right, everybody. So that's it for the talk portion of our night. We just have some closing announcements. Just give me 1 second. Bear with me while I just share my screen. All right, so today was actually, as I mentioned, supposed to be the last night of PyCon, the last night of open source sprints. So you know what? Unofficially, I'm going to be kicking Larry Hastings out of the metaphorical PyCon open sports sprint venue. So that's it for closing out that unofficially. But PyCon is actually going online this year. We're at us.pycon.org. Talks are getting posted. I think Andrews, who spoke earlier, his talk was posted a week ago. He talked about using Django's translation feature to build a multi-language website for his family business. So that was really interesting to see, to use Django to solve like a real world problem. We do have some upcoming events at Chicago Python. We are moving back to our full schedule, just virtually, until it's safe to meet back in person in large groups. So on May 7th, we're going to be doing a virtual algorithm SIG. Folks are going to be out there. There's going to be whiteboarding type of questions, and you're going to be working in groups to sort of solve those types of problems. May 14th, we have a talk on Kubernetes, a talk on Excel, and also a talk on debugging with PUDB. That's going to be our main meeting. May 20th, that's a Wednesday. That's going to be Chicago Python Data SIG. We have 2 talks lined up for that one. Details are going to be announced shortly. May 21st is going to be our virtual project night. We're all going to meet up in Slack. Folks are going to sort of talk about what projects they're working on, and then we're going to just split off into different groups. If you are looking to connect with Chicago Python, we have a very active Slack. If you go to joinchippyslack.herokuapp.com, you can send yourself an invite, get it there. We're also on Twitter. Get news for what's going on within the Chicago Python community, as well as the wider Python ecosystem. And all of this information, plus more, is on our website, chippy.org. Thanks so much for to our speakers for 2 fantastic talks tonight. Really appreciate all of you out there watching. I know it's been it's a little difficult right now, but we're all in this together. If you do need anything, please reach out to the Chippy community. We're here for you. Until next time, Chippy bless.